Okay, you can copy down this triangle right here, and we'll talk about how to find x. All right, ready? Okay, don't have time for the numbers today. You can just call them out here. What type of problem am I working with here? So 30, 60, 90. Guys, do not put in those degrees if they're not in the diagram tomorrow. All right? Too many of you on that first quiz, look back at it. It was a Hill-SAS question, but you decided to pop your own 45 and 30, 60s in there. Now, no. If it's not in there, it's not in there for a reason. All right? But yes, I did put the 60s in there. So now you guys know, yep, it's a 30, 60, 90 question. And I got to find side x. All right, quickly, let's go over the 30, 60, 90 rules for us. What's across from the 30? X, the 60. X radical 3. The 2 is for the 45, 45. And across from the 90? 2x. All right, let's start taking this triangle. Let me highlight it in yellow right now. Let's just focus on this one right here. What side did I give you? The side across from 90. All right, so the side across from 90 is 8. Can you get me? It looks like I'm going to need the side across from 60 to deal with this triangle. Can you get me there? What must have been the side across from 30? 4 divided by 2. So what's the side across from 60? Okay, 4 radical 3. So that's this side right here is 4 radical 3. Now turn your attention to the bigger 30, 60, 90. That 4 radical 3 you just found is across from what angle in this new triangle now? It's across from the 30. And what am I asking for with x? The side across from 90. So what must I do with that 4 radical 3? Multiply it by 2 times 4 radical 3. How can I multiply those? So it'll end up being 8 radical 3, yes. Do you want to do the side across from 60 here? Okay, I'll call it y now. So how do I find that side? What do I do with the 4 radical 3? What do I do with this side here to get to the side across from 60? Multiply it by, okay, ready? Ready? Still going to stay 4. What happens when you multiply a radical by itself? Becomes the number underneath. What's the number underneath? So times 3, so that side would be 12. All right, I'm not going to get more crazier than that tomorrow. Now, I don't know, ready? Hey, just one quick listen here for me. I don't know if any of you, if this is going through your mind, that maybe you're not thinking 30, 60, 90 rules. Maybe you're thinking, oh, I have that side, which is opposite, and that side's the hypotenuse. So maybe you're going to use sine instead. There's going to be a problem with that tomorrow. I'm going to say, leave your answer in simplest radical form. So the decimal you get means nothing. Okay, so I'm still forcing you guys to remember your 30, 60, and 45, 45 rules. Okay? We're all good there. Okay, next question. You got your Regents exam on you? Because that's where the next question is going to come from. Is your Regents exam. And then we're going to do one more question after this one involving some hills and SAS. Number 34 in your Regents exam. Hopefully you got your calc ready to go, degree mode. This one's going to be a beast. I'm going to need everyone's help here. But I wouldn't have picked it if I didn't have faith you could handle it. Okay, you see our diagram. We got a ramp, we got D, we got some stairs.
Here's what I found on the web for diagram ramp to get the stairs. Have a look.
I'm good, thanks. I'm good. Any idea how my voice alone can just press the home button and get it? I don't know either. All right, so we have 6 inches tall, 8 inches deep. Angle of elevation. Looking down, looking up. What do we got? Looking down, looking up. Up. Angle of elevation of the ramp is 4.76. So hopefully we're going to know, hey, elevation tomorrow. That's where the 4.76 should go. Looking up. Determine the length of the ramp to the nearest tenth of a foot. All right, so we got to do the ramp here. First off, I'm not going to use the entire diagram as a right triangle. I am not going to use this bad boy as my right triangle. Why not? Why is that fool? Why am I not going to use this whole thing as a right triangle? It's a right triangle. This whole thing here. Why not? This is where the ramp stops. It's not the whole diagram. All right, so ready? Let me draw in the actual right triangle we're going to use right here. That's where I'm going to use. Everyone see it now? See the right triangle? Bless you, Matt. What is the ramp in this right triangle? Hypotenuse. All right, good start. What about this side we just drew in? Opposite, but I don't know the measurement of it, or do I? What is it? 6 plus another 6 plus another 6. Nice job, guys. That's 18 inches. Yep. So tomorrow, if you have the opposite and the hypotenuse side, I could do sine, but you could do law signs too, right? Right? 4.76, got 18, excuse me, you got 90, and you got the hypotenuse. So you could use law signs, but we'll use sine. Sine of 4.76, keep working with me, equals opposite 18 over hypotenuse, whatever variable you're going to call that. There you go. Everyone all right with that setup? All right, that's why I need my calc here. 18 divided by sine of 4.76. Here's what I'm getting out. How we look? We look all right? Everyone cross multiply all right? We're all wrong. We're all wrong. Right? Our diagram was on inches, but the little rounding there said what? Nearest tenth of a foot. Our answer's in inches. How do I make it into feet? Yeah, divide by 12. That guy. So we're looking at what now? Not 216 feet, but 18.1 feet. That guy. Now look, don't worry about converting tomorrow. I picked this problem because you had to divide that up, find a right triangle, and this second part's still a little tough too. So I'm not trying to bust on you here and say good luck tomorrow. I'm not going to have you convert tomorrow. Don't worry. All right, but you may have to cut up a diagram like we did here. Oh, what do we have in store for this next part? Oh, nearest foot again. All right, keep that in mind at the end. The horizontal distance D. So find D. All right, what side is D now? It's the adjacent side to 4.76. That's the adjacent side. We could do Pythag if you wanted to. We could do law of sines if you wanted to. I'm just going to stay sine, cosine, tangent. So we'll do tangent because I have the opposite side, which was 18. I have tangent of 4.76. Anybody want to finish that? Equals 18 over D, opposite. Opposite over adjacent. What's the deal, Billy? What do you got? Fine. Fine. Good for you. Good. You can do that. Like I said, multiple ways of doing this. Yep. I'm not there yet. All right, not there yet. Eventually I will get there. I like the chatter that's going on because you're seeing probably something that doesn't look right. We getting another 216.166. All right, you might want to hold off by dividing by 12. Might want to hold off right now. Hey, everyone. We didn't just find D. We found more than D. We found the adjacent side in the right triangle we're working with. So what did we just find? There, that's what we just found. The adjacent side in the right triangle. That's 216 point whatever the decimal was. What do I still need to do now to that to find D? Subtract off how much? 16, yes. Subtract out 16. And now at the end, what do I still need to do to find in nearest tenth of a foot? Divide. Now you can divide by 12. $16.7 feet. Whew. All right, we're all good there. I'm not going to have you convert, but certainly something like, oh, I don't have all of it. I got to subtract off a part of it. Be aware of that. Yep. Whew. Take a breather after that one. Got one more for you. Not in your Regents exam. Find a spot for it. Find a spot for it. Just all I need is the diagram down. That's all I need. Here's the diagram. All I need is the diagram down. And we're going to find the length of BC. All right, find the length of BC. based on the diagram alone. I don't care what the numbers are or anything. What type of problem is this? Hill SAS. Boom. God, do not write in 45, 30, 60. Don't write it in. It's not true. You can't prove to me it's true. This is a Hill SAS question. If I am asking you guys to find BC, everyone see segment BC. In Hills and SAS, what do we call BC? Leg. Leg. What's the only one of the two that uses leg? Leg. We okay on how I identify the hills? Yes. You could do that. Yes. That's one way to do it. You got to make sure you know your other segment, but yes, you could do that. Okay, H in hills. Hypotenuse. What is the hypotenuse in this diagram? 12. And hey, let's clear this up because I remember there was mass confusion on quiz 1. When I say hypotenuse, there's only one hypotenuse in hills, and that's the hypotenuse of the original right triangle. Do not give me the hypotenuse of one of the small right triangles. There's only one hypotenuse in hills, and that's the hypotenuse of the original right triangle. The L stands for leg, which in our case, X. What do you know about the two legs in hills? Always the same. All right, now here we go. What's S? Segment. But it's got to be next to the leg you picked. So I don't need 8. I need the one next to X. Anybody know how long CD is? 4. 12 minus 8. So I'm going to use 4, not 8. And then I'm going to cross multiply. X squared equals 48. And then since we are in a little bit above level geometry class, I am going to ask simplest radical form. So find the biggest perfect square that goes in the 48. What do we have? 4 radical 3. Hopefully you pick 16. Radical 16 times radical 3. All right. 4 radical 3. So I just want to make sure we did a hills. We did a sine, cosine, tangent problem and a 30, 60, 45, 45 problem. You got 2 choices. You can grab a textbook, finish the questions we started yesterday in class. The answers are in your packet. Or you can do the packet questions because you guys now know where all my work is. All right, choose. No packing up till 10:07 when the bell rings. If you want to work with other people, that's fine, but you know the deal. Pick your poison wisely. Yep.